go through a few housekeeping bits and pieces like we usually do before we get into the meat of things. Just to let all of you know, there aren't any specific videos for this session, so it's a pure PowerPoint presentation. We will make the PowerPoint available in a PDF copy afterwards for everybody who participates, as well as the recording. So we're making a recording this afternoon and tomorrow morning for the other session. We're going to mute everyone in a few moments just to reduce all the background noise. And if you have any questions, make sure to use the chat box, or remember you can also raise your hand. Irene and Chris are here with me today, and they're going to be monitoring the chat boxes and people raising their hands for questions and all that. So we'll try to take questions as they're pertinent to the content, or we'll wait till the end to answer things as we go. If you're having any difficulty with the audio, please remember that you can also use the local Australia number or New Zealand number to dial in by phone into the webinar. And if you're sitting in but you haven't actually registered with the system, please make sure to type your name into the chat box, and Chris is going to jot your name down for your CPD credits to AOPA. So we'll go ahead and send a list of all the participants to AOPA following the webinar at the end of the week. Okay. I'd like to thank you all again for coming to the session this afternoon. We're very excited now to finally be releasing Unity to the Australia and New Zealand markets. I know many of you probably got a preview of this from the presentation at AOPA last year, and we've worked out a few more bits about fitting suggestions and details in the meantime, and we're really excited to go forward with this system now. It really completes a range of suspension solutions now for the Össur company, and to be able to pair this in a really nice and elegant way with FlexFoot, I think is going to make an outstanding offering for people. So we'll just go through, just to start out, what the advantages of vacuum suspension are from what we've seen with the prosthetic field over the last several years. We know that vacuum creates a very firm suspension for individuals, creating excellent security, improved proprioception and control of the prosthesis. It also tends to assist in maintaining more constant limb volume, which most users subjectively report that they have decreased or eliminated the need to add socks throughout the day. So maintaining that constant limb volume helps maintain that good control and really good comfort in the socket. It also assists for some individuals with wound healing by improving the circulation through the residual limb. You find that if the socket's been well fit with a vacuum system, a lot of scarring in particular areas or areas that have been historically chronically irritated can tend to soften up and heal quite well. We also know that these systems provide good distal comfort for bony or sensitive distal ends, again, as long as the socket is fit properly. And we'll mention as we go through this a number of points about volume and length matching. Matching volume and length are particularly critical with these systems, and we'll get into that as we move forward. So now that we've looked at some of the advantages that we know about vacuum, let's look at some of the pre-existing challenges that we've been facing over the years. Conventional systems have typically required, not in every system, but in most of the systems that are available out there, the use of some sort of suspension sleeve, which tends to restrict knee flexion. They also tend to be punctured frequently and require frequent repair or replacement of the sleeve. Conventional pumps, depending on the system, have increased weight of the prosthesis and bulk of the prosthesis in some instances. Socket fit, again, has to be precise. We know that imprecise fitting, especially with respect to the distal end of the limb, can cause severe tissue damage. So we know that the sockets they really need a bit more time and patience to be able to get the fit correct before you move forward with the definitive. Suspension can be compromised if the seal fails, again, typically due to sleeve punctures and tears. There is potentially more maintenance with respect to a vacuum pump mechanism in dealing with that if you compare it to expulsion valve systems, and there is also the increased expense related to these systems compared to basic expulsion. So we'll touch on a lot of these points as we move through this presentation with Unity. So before we get into all the details, we've talked about advantages, we've talked about challenges of vacuum in general. So now I'm going to outline to you the key points here of what we find beneficial with the Unity system from the broader perspective. A, it's sleeveless. So all the issues dealing with sleeves, particularly knee flexion range, comfort, overall user acceptance, is going to be much improved because the system is inherently sleeveless. It's lightweight and discreet. The pump itself is integrated into the FlexFoot module and housed within the foot shell. It only adds 130 grams of weight to the entire system. So if you compare it to a lot of the other pure mechanical systems that are available out there, it's a nominal amount of weight, not adding any additional build height to the system, and everything's nice and cosmetically housed within the foot shell. It's a simple and efficient pumping mechanism that you'll see. It's quick and easy to elevate the vacuum, and also because of the tri-function valve we have, it's very easy for folks to release the vacuum levels as they need to either take the prosthesis off or potentially to decrease the vacuum levels, for example, if they're sitting for a long period of time. The independent pump, this is another feature I found particularly interesting. We're not depending upon any particular shock mechanism added to the foot to make the pump work. So the pump works simply off of the deflection of the Carbonex heel on the FlexFoot, which means that we can add it to virtually any FlexFoot system that incorporates our heel. So the foot operates completely independently, and we can add this to a wide variety of foot systems. The volume stabilization attributes are quite good with this system as well. We're pulling up to 22 inches of mercury on the system, which is quite a reasonable amount of vacuum for volume stabilization. So this is, again, going to help us optimize socket stability, proprioception and control, and comfort for the user throughout the day. Another big feature is the increased reliability, and this goes back to not using sleeves. I think users are going to find this a much more reliable system because you're not constantly getting sleeve punctures or needing to replace sleeves as time goes on. You'll also find, we'll touch on as we move through the program, that this system is completely maintainable in the field. So we have small service kits where you can replace barbs, you can replace membranes and small bits and pieces as you would need to the system. And finally, as we mentioned before, this integrates all the performance FlexFoot technology that people like. So it's a nice and complete system. In terms of folks that would be able to use this system, we're looking at candidates that are transitive amputees, anywhere from low to high impact level, that's fine. We've got foot systems that can meet any of these mobility and activity needs. The weight limit itself is going to be entirely based upon the recommended foot module that you're using in category. So choosing a Unity system, you're going to choose the FlexFoot you want and the category of that foot just as you would normally. Cylindrical shaped residual limbs tend to work best with this system with sufficient length to use the Seal-In V, which we're going to go over. So there is a liner very specific to this system called the V. As most of you would know, working with Seal-In systems before, cylindrical shapes are wonderful with Seal-Ins. It's really different with this. However, we have found that quite conical limb shapes can also be addressed with the use of a distal cup. These are cases you might want to talk with us on the phone about before you go forward, just to see how you want to work with those cases, but it is possible. Some very specific contraindications would be very short residual limbs where you cannot use the standard Seal-In V. That would be a contraindication for use. Also, when you cannot make total contact distally between the liner itself and the residual limb. So, for example, deep scarring, invaginated tissue, you would absolutely have to find ways to fill these areas very carefully and make sure that you have total contact maintained at all times. I can't express how much you can damage the tissue if you've got an ill-fitting vacuum system. So total contact is huge. You've got to make sure that that's maintained. Lastly, if you're expecting significant volume changes, you'd want to work with somebody who's been through their preliminary socket fittings and has somewhat of a relatively stable limb volume before you start this process. So let's get into the nitty-gritty. We've got the building blocks here of the Unity system. So the first part of that we're going to speak about is using the Seal-In V liner. And we'll explain some differences of how it's unique and how it works and how it's different from previous Seal-Ins. The second is the socket connection. We're using a tri-function valve that I think most of you will find really interesting. We're also, again, using FlexFoot, and we've added quite a number of feet to the lineup that you wouldn't have seen at AOPA last year. So we now have the Reflex Shock, the Reflex Rotate, the LP Rotate, Veriflex and LP Veriflex, and Proprio. You can use any of these systems with Unity now. And the vacuum pump mechanism. We'll go through specifically how the Unity pump works. Okay, so first let's go through the Seal-In V. The Seal-In V is a special system primarily because it's using a dual sealing membrane. It enhances the seal retention. So if you're familiar with our X5 system, the X5 works through kind of the principles of redundancy, right? If we've got seal in one place, but one of the seals perhaps gets a small leak, well, the other one's going to back it up. That's the same idea with this, that we've got redundancy within the sealing mechanism. And again, it's inside the socket. So we want to have something that's quite reliable in terms of the seal. It's also using, if you look at the image on the right-hand side, these volume adaptive blades that are on the inside. So if you invert the seal, you can look at all these little fins that are on the inside there. Those tend to help press the seal out against the wall if there's some changes or loss of volume for whatever reason. It tends, again, to improve reliability of that sealing mechanism against the socket wall. It's also quite good under vacuum because when you pull vacuum on this system, you imagine that everything's pulled out towards the socket wall, while all those little fins sort of create a little bit of an I-beam effect inside of the seal itself and prevent it from folding or buckling. When the engineers had tried to do this similar thing with the HSM liner, for example, they found that it tended to leak and that it tended to fold up on itself and wrinkle. So this can really take the application of vacuum quite well because of the seal design. We're using the Dermogel silicone, which is the softest durometer available. This is for distal cushioning, but it's also to have something that's quite compliant to be able to move and conform to shapes. Obviously, with vacuum, as we mentioned before, we want total contact, and we want something forgiving as a material. And so this is going to be good for addressing distal comfort and conformation to limb shape. We're using the active skin care and the silken inner surface as we do with all the premium liner systems. And I wanted to emphasize to folks that this is compatible and it was designed for use with elevated vacuum, but it also works exceptionally well for expulsion-only sockets. So this is another alternative to use instead of perhaps the HSM version or the X5. It's quite a valid and secure type of liner to use for expulsion fits. And you'll note that there's two different sealing options that are available, one with a lower profile seal, the standard, and the high profile that has the seal sit 35 mils higher. Again, I think an attractive alternative for folks that have used HSM in the past and you're looking for something possibly more secure and the ability to bring the seal higher inside the socket to give you better and more comfortable suspension. So just to kind of look comparatively within our own systems, again, compared to the HSM, you have the second seal-in membrane to enhance security. Again, less prone to fold or buckle on itself. It helps to evenly fill in space between the liner and the socket with the blades, and will provide you with a little bit better rotational control. That's another, the volume adaptation point here is another one. If you were looking at retrofitting one of these to an existing HSM socket, I would say that you may be able to do that. It would depend on how much that person has lost, perhaps, volume in the time they've been fit. Certainly one of the things that you could try, you could see if it worked in the existing socket, and if it didn't, you could work on making another socket for that person. Compared to the X5, it's going to be a bit more forgiving in fit with respect to shear force distribution around the tissues around the seal. I think folks of you that are familiar with the X5 with TT fits know that there's a lot of shear that's reintroduced into the socket between the limb and the socket wall again. And this is going to be a bit more forgiving because the seal is not bonded the entire way across the liner as you see with the X5. It's going to be a little bit more forgiving like the HSM that way. In the case of volume loss, another plus, we can tuck those socks, if we do need to add socks, underneath the seal. Okay. I have seen, for vacuum application, I have seen folks also add half socks underneath the seal in some cases. There's superior seal retention with respect to tissue movement. For example, if people are having muscular contractions inside the socket, you get very good seal retention as opposed to with the X5, the seal kind of moving with the contractions of the tissue inside the socket. There was a question that came up, when would you use the Seal-In V over the HSM? I tell you what, the only thing that really rings true for me with HSM possibly over the V is if you've got somebody who's very, very sensitive in bony areas where the seal would be. The V is a bit fatter. The seal itself has a little bit more girth to it than the HSM, where the HSM kind of flattens out precisely in the socket. That is the only point that I see really with HSMs over the V so far that I've seen is that. Yeah. So if they're very, very sensitive over bony areas, that might be one reason to stick with the HSM for now. But I tell you what, you'd be surprised how comfortable it is and how well it does work even over bony tissue. We've had folks using the V over areas like the fib head that tend to be pretty sensitive, and we've still been able to get good socket comfort out of those fittings. With respect to product sizing, we'll just go through some sizing requirements with this. You're going to measure the circumference of the limb 4 centimeters from the distal end of the tissues, as you would with all of our liners. You're going to select the liner as measured or the next size below the indicated measurement. So these are sized exactly as you would our locking liner systems. It's no different. Okay. You do have the choice of a standard or a high-profile seal, so the different seal heights, and that depends completely upon limb length, and yes, there is a chart. So on the next slide, we're going to go through a little chart how that works. That's pretty critical to get right. On an average, the minimum residual limb length is about 10 to 13 centimeters for a standard and 13 to 16 for high profile. It really depends somewhat on liner size. That's why we have the chart. And these are just some examples here below of sizing. So seal height. The Seal-In V seal starts for the standard at 5 millimeters above where the cup basically starts, at the distal radius of the liner. And the high profile starts 35 mils proximal to that radius. The liner cup size varies, which affects the minimum residual limb length. So that's why we have the little chart there for you to reference, that as you move from smaller sizes to larger sizes, you're going to see obviously different minimum residual limb lengths listed on the right-hand side. So be careful to have a look at that chart. Also, just another little rule of thumb I would keep in mind is looking at mid-patellar tendon to the distal end of the limb only gives you a rough idea of total limb length. If I were most of you, I would look at MPT to distal end minus about 2 centimeters, which is typically where your posterior wall gets trimmed around the medial hamstring, is about 2 centimeters below mid-patellar tendon. So I would consider that my actual limb length. That's not stated here on the charts. That's just a little rule of thumb that I would use. Now we'll take a look at this trifunction valve. This is the valve that we recommend you use with Unity. You'll see, for those of you familiar with the 551 series, it's quite similar. It's kind of built on that, except it has an additional function where we're pulling vacuum through it as well. So we still have the expulsion features. As someone pushes into the socket with the V and the air has to come out, well, it's going to allow the air to expel automatically. The vacuum bypass, the little barb on the distal portion of it, allows us to pull vacuum through that one-way valve, so that we can use the Unity pump. And then the release button, obviously, if someone needs to take the socket off with a system like this, unlike a sleeve system, we have to have a release button. So this is to allow the person to pull out of the socket so air can come in. But also perhaps if someone's sitting on an airplane for a long period of time, or driving a car or whatever it might be, and if they don't want to feel a higher level of vacuum that they've drawn inside the socket, they can release that and just be potentially more comfortable when sitting. Okay. The Unity valve, it doesn't add any build height, obviously, to the prosthesis, so you're mounting this through the socket wall. I would recommend that you mount it medially or posteriorly if you can, to avoid issues with knocking the valve against something, being that I think you'd have particular problems with that if it was on the lateral side. So I'd really avoid that lateral placement of the valve and the tubing. It also has a built-in particulate filter. This is obviously to keep particles of dirt and things out of the system as much as possible. I would recommend that you disassemble the system completely before you trim it. Obviously, metal shavings and duckbill valves and seals are no good. And we need to make sure that the valve itself is sealed to the socket inner wall. So there is a plastic valve insert that this comes with. Most of you might have ignored these in the past. They were intended when we had these with 551s, and we still do. They're intended for flexible sockets. However, this valve insert, this dummy that we have for the positive model, we'd like to see everybody using that with Unity as a standard. It's simply going to help avoid leaks between the socket and the valve. So we want that sealed up with silicone with the valve insert installed. Okay, and using any good industrial grade silicone sealant will work just fine. So now we'll get to the foot portion and the Unity pump itself that's incorporated into the flex foot. How this works, if you look carefully to the diagram on the left, I think the construction of it, when people first look at it, it looks a little confusing, but it's actually quite simple. There's a certain elegance to the design that's been incorporated to this. It's really simple. There's a carbon fiber frame and support blade. The support blade basically sits attached to the flex foot itself. So you'll see whether it's a low profile or a standard J-shaped flex foot, you'll see a blade that comes down from the foot module portion and extends out over to about the mid-foot. Attached on top of that is the frame itself for the Unity. So that frame has the membrane incorporated into it, the check valves, and a heel pad. And that basically rests on the carbon X active heel. So when the carbon X active heel deflects, that frame is deflected with it and basically pulls on a small circular bladder that sits between the frame and the support blade. As that bladder expands, you've got check valves that operate, and we draw air out of the socket. using that valving system. So it's very, very simple. The check valves you see in number 2, they're assembled for a left foot from the factory. Now those little check valves can also be taken apart with a little 8mm crescent wrench, and you can swap them if you want the tubing to run up the opposite side for a right. That's no problem. So you can swap those out. Also, that means that these can come out to be cleaned, to be replaced. The membrane itself is removable from the bottom, so if you ever had a membrane that failed, you can replace that as well, all in the same unit. We have been informed from America that they haven't had a single support blade break yet. They've been working with this system for about a year now, and they haven't had any failures, which is really great news. So we feel like we're pretty confident with the reliability of this system. As I mentioned earlier, fitting a flex foot with the Unity is really no different from any procedures you've been used to in the past. You're going to simply select the size that you want and the category, no different than what you normally do. Get a good static alignment, and remember to use your heel wedges. I think that's another thing that folks are surprised about, is that you can still use the wedges with the flex foot. It's no problem with this. The wedges just sit in that small joined space between the foot module and the heel module, and sit in front of the heel pad. So there's enough space in there to be able to actually use the wedges as well. The Unity pump can elevate vacuum and will up to minus 22 inches of mercury. However, most of the normal operating pressures that you find will be between minus 16 and minus 20. The added weight to the system, that's the pump, the valve, and the tubing, is about 130 grams. And again, we recommend running the vacuum tube medially. Simply avoid that lateral placement of valve and tubing, just so you reduce chance of impact with foreign objects out in the environment. And as I mentioned before, the valve and exhaust ports are interchangeable right-left. The feet we've got compatible with Unity at this point are the Proprio, the LP Veriflex, the Veriflex, the LP Rotate, and the Reflex series. So with this, you can really meet a wide range of activity demands from people out there that are looking for a system like this. So, and we're excited that there may be other feet added to this lineup as time goes by. So now let's talk a little bit about the clinical aspects of this. I find that this is the simply most critical thing about Unity. So if you've missed the rest of this or you've started to doze off, this is the time to wake up. The casting method and modification method are really, really important. I'll say this, your fit with this has to be precise. You're not going to find the same amount of forgiveness as you would with seal-in fits with expulsion. You can be a bit off on your percentages or your length, and your fit's still going to be all right. You're going to get away with certain things that you don't once you put vacuum on it. So with respect to this, casting's pretty important. We've found that, or I'd recommend to you that you at least take circumferences and an M dimension in terms of measurements on the patient. Take a neutral cast, meaning in about 3 to 5 degrees of flexion. I usually tell people just to unlock the knee joint and then take a cast using elastic bandage first. I take it directly over the cellophane with marks on it, and then with rigid plaster over top of that. Wrap from proximal to distal. I would suggest you don't wrap tight and avoid tightening the cast. I know we've taught people for years to tighten the cast with seal-ins for casting that way, also for locking liners with lanyards, we've taught that, and for those it's fine. But an overly tight cast with this system does not do you any favors. I guarantee you that. So you'd rather just take a very simple elastic and then rigid on top. The other thing we found is that casting under vacuum is not necessarily required. I've done it several times. The difference between doing it with vacuum and doing it with this neutral cast with elastic and rigid is minimal. I don't find there's really that much difference. For those of you that love casting with vacuum, I don't really have a problem with it because I've found that it also does work. It's just that my feeling is that it's extra work. You don't necessarily have to do that if you don't want to. But again, those of you that have the habit of casting with vacuum, it works, it's fine if you want to continue that. Modification-wise, correcting the ML dimension is pretty critical. You're not pulling vacuum up at the ML dimension. You're pulling vacuum from the seal down. So I'm finding it's pretty critical to make sure you get that ML dimension as correct as you would on anything else. You want to level out the seal area on the positive. So you're doing that as you would do with the rest of our seal-in range. We're finding that about a global 3 to 5% reduction, and in most cases I found 4%, is a pretty good place to start. Now that means uniformly across the whole model. It's not a tapered reduction as with the other systems. Okay? And you're taking that reduction off of the patient measurements. Okay, so calculate that off of the patient measurements, not off of the positive model. Remove about 6 millimeters distally. That seems to consistently work pretty well, that distal reduction. You'll find that if you don't take that 6 millimeters off distally, you get people with an incessant pulling sensation that's really irritating, and they feel they got to take the leg off. It might not happen your first day. It may happen a couple days afterwards. So you have to be careful and make sure you remove the material distally. And last but not least, remember to attach the valve insert before you pull your check socket, or more particularly your definitive, so you can avoid leaks between inside the socket to out. When you get to your check socket stage, you want to make sure you take a look at the seal real closely. It's ideal, once again, to choose the seal and make sure you fit that as high as possible on the residual limb. Really try to pick your profile as close and as accurately as you can before you start. I do find that after you modify these sockets, retrofitting the low profile seal after you've already casted with the high profile doesn't necessarily work very well. So it's going to be best if you get this right from your measurements to start. You want to have equal distribution of the pressure around the seal as much as possible. And that seal, make sure that it seats at least 1 centimeter. I'd suggest if you possibly can 2 centimeters below the posterior socket trim line. You don't want that seal peeking up across any of your trim line back there posteriorly. The pressure on this seal can be read pretty easily as you'd read it with some of our other seal-in systems. This one's maybe easier to read because of the blades on the inside. They tend to press up, and it looks a little bit like a tire track when it presses up against the socket wall. Normal pressure when the system is de-weighted, you'd see about 50% compression, where you see that green line on the seal, and that means you're not going to get any kind of leak even when the system's de-weighted. When they're fully weighted, you'd expect that to be pressed out almost 100%. If you're seeing pressure areas where you're not seeing the ribs, the blades that are pressing up inside, it's a little sketchy. It probably means your socket's a bit too loose. Okay. In terms of further evaluation, the rest of the things here is all about 2 things, volume and length. I can't say it enough times, volume and length, volume and length. Your volume and length has to be right. So these are just suggestions to get you started in terms of evaluating volume and length. Basically, once you get them in the check socket, you can add a silicone spot. These are like the silicone pads that we have. We also get some larger silicone pads from Evolution Industries in the States. If you don't have these in your facilities, we can help you get your hands on these really easily to do the distal volume check. But basically, you want to add one of these spots to the bottom of the socket, and you want to see if the client you're working with says if it feels better, worse, or the same. You basically want to be, if you add a pad and it feels worse, then you're probably already correct. And in most cases, when I do that 6 millimeter reduction off the bottom, I'm finding that I don't need to do anything with these pads. Okay. but it still is a good secondary check to see if you're close on the length. So you just go through the process of if it's better, worse, or the same, and you're adding spots until they're saying that it's better, or if you've already done the job, and it's as good as it gets after you've done the pad check, well, then there's nothing more you need to do to it. The circumferential volume check works on similar principles, but as we're used to, you use socks. Now, here's the trick about it. Using these socks, you're just disregarding the seal against the socket wall with this. What you're doing is you're putting on one-ply socks and you're stacking them on there and going through basically a static check to find if you're getting better comfort out of the system or if it's actually worse or the same. And again, you're moving to a point where you'd like to see them say that it's better. And if you're determining that it's better, you're keeping track of how many ply that is, and that's how much you've got to remove off of your model, okay, to make it better. So once you've added up the length check and the volume check, you know how to further optimize that socket. Now, I'm not going to dictate to you whether you do a second check socket or not. If it's me, I probably would. This is up to your clinical judgment in terms of how you want to handle these modifications. Okay. In terms of definitive socket structure and materials, these are definitely things you have to do always. Anything with vacuum, you've got to use a PETG layer over the positive. You have to do this. If you haven't done this with expulsion valve fittings in the past, a lot of people are already doing this with seal-in fits as a standard. If you're not, I would suggest that you think about doing it. It's really fantastic for the sealing against the socket wall. But more importantly with this is that laminate leaks. And when you're pulling vacuum is going to leak through the lamination. So you have to have a better seal than lamination, full stop. So you've got to make sure you pull this PETG layer over the positive with the valve insert attached to the positive model. Then you go ahead and rough that up and you laminate over top of that for your structure. In terms of identifying socket leaks, when you're using the PETG to seal the socket, there's potentially three main places where you might get leaks. A is across the seal, especially when someone's walking. So you want to make sure that you address this in the check socket fitting, so you don't figure out in your definitive fitting that this was a problem. So make sure you really look at how that seal conforms to the socket wall. You don't have any spots that are poor in terms of pressure distribution. You can also leak through the seal. So make sure you double check that your seal is not damaged in some way. Okay, this would be more critical for things to check on follow-ups and down the road with somebody. Okay. And finally, across the valve seat. So again, remembering to use that insert that we've got to put on the positive model, and that you're sealing everything with silicone sealant. The last thing I might add here is that tubing can also wear a little bit over time. So that's also critical with respect to your valve placement, that tubing's not being bent around the barb and things like that. That's also where you can get small leaks. In terms of warranty and maintenance, the standard flex foot warranty is going to apply to the foot module itself. The Unity pump hardware kit itself has a 24-month warranty, so if anything happens with that at all, we'll replace it outright. The Unity membrane, which is the small rubber membrane that sits inside of the pump itself, has a 12-month warranty on it. Anything happens with that, we've got the service kits we'd automatically send out to you. Those can be swapped out. And the Seal-In has a 6-month warranty. As I mentioned a number of times, the Unity is completely field serviceable. You can take everything apart in the field, clean it, replace it as you need to, and those maintenance kits will have available to you as you need them. Finally, I will say this. The support blade that runs off of the flex foot will also tell you this. If anything happens with the support blade, we consider that part of the foot module. Foot gets replaced itself. Okay. Again, so far we've been told there haven't been any failures of these blades in the field, so we feel pretty confident that you won't have problems with that. And in terms of service and clinical support, we're not requiring you to have any specific training for Unity. However, if you want training beyond what is involved with this webinar, we're very happy to come and help you and give you some fitting support on the first one as you need it. So just ring us up, coordinate with Chris and myself on that, and we'll try to come and see you as soon as we can. We are asking everyone to use order forms that we've developed. Irene has made a lovely online order form and fax version that are available now. We want everybody to fill these out, A, because it makes it easier for you, and B, because it makes it easier for customer service to make sure your order's complete. Okay, so I think it's a win-win for everybody to use these in the beginning to get familiar with the system, because it is everything from liner to valving and foot and pump all together in one thing. There's a full brochure on Unity that's going to be released this month that may be helpful to get some further education for yourself, but also perhaps for you to use to talk with clients that come into your facility and are interested in the system. You can discuss it. It's quite a nice brochure, and it really is complete in terms of the information there, and something that I think will help for education. And all the Unity system components are listed in our new 2014 catalogs that have just come in, and those should be getting out to you very soon. And it looks like we've got a couple more questions here. How does the strength of vacuum compare to active vacuum pumps? I'm not quite sure what you mean by active vacuum pumps, if that means electronic or other mechanical vacuum pumps. What I can tell you is that minus 10 inches of mercury is what is considered to be medically beneficial for folks in terms of circulation and so on, and volume stabilization with elevated vacuum. So what this system is delivering is above that. It's not as high as the original Unity. The original Harmony systems that were developed by Tech went as high as minus 28. But most people have found that that's a bit too much, that most people wouldn't need that high. So the range that we've got is pretty reasonable, up to minus 22. And this system will pull to full vacuum over a series of steps. So there's no bleeder on it. There's no way to sort of program a certain level of vacuum into the system at this point. That's another reason why your socket fit's got to be spot on. All right. If there's any other questions, guys, please go ahead and just send them through on the chat. We'll maybe take everybody off mute right now, and you can either talk through or you can chat through however you'd like, but let us know if you got any more questions. I'd like to thank everybody for attending today. It's fantastic to see everybody turning out for these again, and we look forward to the next time. We're going to stick around for about 5 more minutes and see if folks have any more questions, and then we'll probably sign off. So thanks again, everybody. Much appreciated. If you haven't sent your name across to Chris for your CPD credits for AOPA, please remember to do that before you sign off. Thanks.
Oh, Ella?
Yes.
You can type that if you want. Yeah, I'll just type back.